This is section 3.3, part 4, where we're going to graph a system with an absolute value inequality. So, we've got a system of inequalities, but this one's not linear. Alright, we've got a linear inequality here. This one is not. Absolute value, we know from previous sections that it forms a V. Alright, so it's not linear. So, we need to graph both of these, and then we're going to work with our shading. So, first things first, we have y is greater than or equal to 0. So I need to plot a point right at 0. Plotting a point at 0. Alright, what happens when you're at 0? Do you have a horizontal or do you have a vertical line? So digging deep, you remember, yes, we have a horizontal line. So I'm going to draw a horizontal line greater than or equal to, so it's solid, and it's going to pass right through 0, y equals 0, and it's really going to run right along the x-axis. Alright, that is one of our lines, right along the x-axis. The second one, alright, we've got the absolute value of x minus 1. So if you remember graphing with absolute value, you can definitely tell your vertex. Alright, so we have, alright, I'll maybe have y is less than a times the absolute value of x minus h plus k as a reminder, and our vertex is going to be h comma k. So what's our k out here? Oh, that's a plus 0. What's our h? It's the opposite of this value because of that negative. So our vertex is going to be actually 1 comma 0. The opposite of negative 1 is 1, and then we take whatever the k is. So our vertex is 1 comma 0. So I'm going to plot that point right here. And then the a value kind of acts as slope. What number's out here? Oh, that's 1. So from our vertex, I'm going to go up 1, right 1, plot a point, come back to the vertex, and then go up 1, left 1, so we can get our V formation. Because it's less than and there's no equal to, we're going to have a dashed line, so we're going to have two rays extending from the vertex, and they will be dashed. There's the one side. Here's our second side. Dashed. Okay, so that's half the battle. Now we just have to test for shading. Okay, so unfortunately with the first equation, or inequality, y is greater than or equal to 0, I can't use my favorite test point of 0, 0, because this line passes right through it. So I'm going to use my second favorite test point of 1 comma 1. Alright, so I've got y is greater than or equal to 0. I'm going to plug in, instead of y, I'm going to plug in the value of y, which is 1. Is 1 greater than or equal to 0? Yes, it is, so that's true. So I'm going to want to shade in the direction of 1, 1, which is up. Alright, so I've got some nice shading, alright, going up from this line right here. Now I have to decide what am I going to shade with my V. Am I either going to shade inside the V or am I going to shade outside the V? Alright, and we can tell by plugging in 0, 0 for this, because the V does not hit 0, 0. So I can use that as my favorite test point. Test point here, 0 comma 0. And I've got y is less than the absolute value of x minus 1. So I'm going to plug in 0 for y, absolute value of 0 minus 1. Simplify. 0 minus 1 is negative 1. So I've got the absolute value of negative 1 is 1. So is 0 less than 1? Yes. So it's true. So I'm going to want to shade the region that includes the test point 0, 0, which is outside the V. So I'm going to shade outside the V. And where do you see an overlap? Well, I see an overlap in two places. I see one over here. So it's above, it's in the positive direction, it's above the x-axis. And I also see an overlap right here. above the x-axis. So I'm going to make that a little darker, and both of these make my solution. Any point I pick within the shaded region will be true for both of these inequalities. And that's the end of section 3.3.